So, dear students, good morning. Today we are going to further continue this lecture series. So, in the last class I introduced about input-output devices. So, input-output devices are called peripherals. Now, in this lecture series, in this video lecture, we are going to introduce about what is called I/O interface, input-output interface, right? So, it's very essential to understand this. What is this interface and what is the purpose of this interface, right? So, you know that in a computing system we have a CPU, right? So, we have a memory, right? So, the first thing is, so how CPU is connected to memory. So, CPU is connected to memory with the help of buses. So, one, right, there are three buses. One bus is address bus, right? So, address bus, so is unit, right? Then data bus, right? And control bus. So, to the memory, CPU uses especially two control signals. One is the read control signal, another one is the write control signal, right? So, having set this connection, so what CPU can do with the memory? So, CPU can either read or write. How CPU read or write from the memory? So, by executing the instructions, right? For example, we have an instruction called load, right? So, if CPU executes load instruction, right, what happens? This address will be the address from where to what is load instruction. Load means from particular memory location to we need to load a data to the accumulator. So, we have a register inside the CPU called accumulator, right? We want to, if I execute this load instruction, what happens? So, the address to which we need to load the operand, that address is kept in the address bus, right? And the read signal is activated. Once the read signal is activated, the memory has a memory controller inside it. So, this memory controller, what it will do? It will take the data from that address and keep in the data bus, so that from the data bus that is transferred to the accumulator. So, this is one instruction we can execute to read. Similarly, to write, we can execute the store instruction. So, what is the store instruction? We want to store some data, we keep the data in the accumulator, then we execute this instruction. So, what happens? The data present in the accumulator is kept in the data bus. Similarly, the address to which it is sent, that is kept in the address bus, and write signal is activated, so that this memory controller will read this data and keep this data in this address, write this data in this address bus. So, these are the two instructions which is used to perform the memory operation. Similarly, we can introduce, now our intention is to introduce I/O devices, right? So, to connect an I/O devices, we cannot directly connect. So, assume that we are connecting I/O devices to the same bus, right? Now, to connect this I/O devices, remember that we cannot connect directly. We need an interface, right? So, we need to connect the I/O devices via interface, right? So, for example, I want to connect a keyboard, right? So, I require a specific interface for the keyboard, right? So, this interface is connected to this address bus, right, data bus and control bus, right? Now, similarly, this interface is connected to the keyboard. Of course, between the keyboard and the interface we have a controller, right? So, we have some controller, right? So this is the thing, right? So, for example, so this is a keyboard, is, you know that it's an input device, right? Similarly, we can connect output device or input-output device. So, for every device we require an interface, right? So, for every device we require separate interface. For example, you want to connect a printer, I require an interface. I connect address bus again, data bus and control bus, right? So, this interface is connected to the printer, right? So, in between interface and printer we have a controller, right? Interface controller, we have a controller, right? Now, this is the set of connections we do, right? We have a so similarly printer is an output device. Okay, so similarly printer is an output device, right? Now keyboard is an input device. Okay, now see what I'm telling is, so if you want to connect a CPU to this input output devices, we require an interface, right? So what does this interface is required? So the interface specifies the way of communication. For example, you take the practical scenario, I want to connect a mobile phone to your CPU. How you connect? You connect a USB or you connect via Bluetooth, right? So this USB Bluetooth are called interfaces, right? Or you want to connect your computer to a network, to the router, you connect via LAN, so that is one of the interface, right? Or you want to connect a wireless via Bluetooth, via Wi-Fi, so that is again wireless interface. Like that, want to connect a IO devices to this CPU, so you require, for every device you require a specific interface, right? So first of all, let us see why this interface is required. So that is the first question. So so before that question, let us see. Now having connected with this interface, now CPU want to communicate with this devices. Suppose CPU want to, what it can do from this input device, CPU can read the data, right? We know that in our basic computer we have an input register, right? So we have an output register. So suppose CPU want to read the data from the input device, what it can do, it needs to execute an instruction called input instruction, right? So if CPU execute an input instruction, what happens? The keyboard, right? The keyboard, whichever the key you press, that key is transferred to the, via controller it is transferred to the interface, via interface it is transferred to the input register, right? Similarly, CPU want to transfer something to the output device, what it will do, it will execute this instruction called output instruction. So what output instruction will do, whenever you execute output instruction, the data returned to the output register is sent via this bus to the interface. From this interface it is sent to the controller it is sent to the printer. So this is a way, so this interface helps in helps in communicating the CPU with this input output devices. So but why this interface is required, right? So that question we'll see. So why this interface is required means, for example, so this is what I'm talking about. So input output, okay, so input output interface, it provides a method for transferring the information between internal storage and the external input output devices, right? Now, so why this interface is required? For example, you see here the CPU is connected to this input monitor, keyboard, hard disk, each has its own interface, right? So this interface, right? So this interface will provide a special communication link, right? So the special communication channels, right? So the special communication channels are required to resolve the differences, right? So what are these differences? So this interface is required. This interface establishes a special communication links, right, between CPU and the specific IO device, right? So after all, why these communication links are required, right? So they are required to, right, to resolve the differences. So what are the differences that exist? Okay, if you observe this, for example, the first thing is, so your peripherals are input output devices, they are electromechanical devices or electromagnetic devices, but your CPU is an electronic device, right? So there is a lot of difference, right, in the operation. For example, basically your CPU will operate with something called a TTL logic, right? So it will operate typically 3.3 volts or 5 volts, right? Now your IO devices will operate in a different way, right, in a different voltage. So this interface, what it will do, it will convert this voltage from 3.3 to maybe some 10 volts, right? So this interface is used for the signal value conversion, right, conversion of the signal values. This is one of the purpose. Similarly, since the CPU is an electronic device, speed is very faster. So but IO device speed is very slow. So how it, so interface acts as a buffer. So suppose CPU will transfer some data, it will transfer to the interface. So interface will buffer the data, so that whenever the that input output device is ready, then it will transfer this data buffered to the IO device. Like that, it will synchronize the operation between CPU and the input output device. Like that, interface can act as a buffer between CPU and the IO device. Also CPU uses some different formats. Maybe CPU may use parallel or IO device may use serial. So interface may convert from serial to parallel and parallel to serial. So this is another thing. So also the CPU may have different operating modes, right? So IO device may operate differently. So interface, right? So interface will take care of that. So without disturbing other operation, right? So it will properly able to talk to the specific IO device. Now if we consolidate all the operations performed by the interface, we can consolidate into three things, right? So the three things are, one thing is data conversion, right? Another thing is synchronization, another thing is device selection, right? So what is data conversion? So your CPU may be operating digital data, right? So maybe your this IO devices may operate on analog data. So this interface converts from digital to analog or analog to digital, or your CPU operating on parallel data. Your IO device may operate on the serial data. So this interface will convert from serial to parallel and parallel to serial. So that is a data conversion. Also synchronization. Synchronization means this interface acts as a buffer, so that whenever CPU transfers the data, it will buffer it, so that when these devices are ready, then from this buffer it will transfer, so that the operation of CPU and this device will be matched, right? So similarly there are many devices, right, in this, for example monitor, keyboard, hard disk. So all these devices, CPU want to talk to any device, so this interface is responsible for selecting that particular device, right? Now see, so this is the purpose of an IO interface. Now we understood that, right? So CPU is connected to IO device via an interface, right? So we seen the what is the purpose of this interface, right? So having understood this purpose, now CPU, right? CPU can communicate this via this uh, using this IO input instruction and output instruction, right? Now see here, now having understood this, now let us see the concept of function code or input output command, right? So for example we have a printer here. Suppose CPU want to send a communicate with the printer, like it want to turn on the printer, right? Now CPU will give some command, right? CPU via, of course CPU will talk to the output via this output register, right, via this output instruction, right? So there will be some command, maybe some F2, some command is there. This command is sent by the CPU to the printer, so that the CPU will this printer will start printing, or CPU want to command the printer to stop printing, so it may send via some code, right? That kind of codes is called, we call it function code, right? So this function codes, see what I'm talking is CPU want to so that CPU want to talk to printer, it want to talk in some kind of language, so it will, so there will be some codes, so that CPU will understand that code and printer will understand that code, so that if CPU transfer that code to this input output devices, that it can control them, right? So what kind of codes it has? So if I generalize this concept, the codes are divided into four types. One is a control, that codes are called function codes or IO command. So one kind of code is control, right, control code. Using this control code, CPU can control this IO devices. Or there is another code called status code, right? So using this status code, CPU can check the status. For example, if we have any printer problem is there, it stops printing due to some error, so that CPU can check the printer status via some status command, right? So all like that, so it can know the status of this particular device with the help of a status command, by reading the status of that particular device, right? Also we can send the data, right? So data in command, so we can send data from some input device to the CPU, so that is called data, right? Like if you press any key in the keyboard, that corresponding ASCII value will be communicated to the CPU. This is called data. Similarly, data in, another one is data out. So data out means, like, so CPU can send some data to the output device via this kind of infrastructure, right? Now, so these are the four function codes which is used by the CPU in order to communicate with that particular input output device. So let us consolidate the discussion. So what I told, so CPU can able to, right, if you want to connect this IO devices to the CPU, we need to connect to this bus via interface. So each device has its own interface. So we have seen what is the purpose of this interface, right? So now CPU will talk to the IO devices by executing this instruction, input output instructions, right? Or CPU can want to control this kind of IO devices or know the status of these IO devices, it or send some data to these devices or read some data from these devices. So that can be done with the help of these function codes, right? So they are control code, status code, data in, data out, right? So let us continue this discussion in the next class. Thank you.